Anything from 6.1? You can throw them up in the comments. Anything? All right. Well, one that we can do that kind of relates two of the big topics from section 6.1, and it doesn't take us very long to do that. We'll do number 6. So number 6 is one that's going to practice the main ideas from section 6.1. So the big thing from section 6.1 is looking for interior angles. And the formula for finding interior angles is taking 180 degrees, excuse me, times the number of sides minus 2. So if I wanted to find the total number of degrees in this figure right here, I would take 180 times the number of sides minus 2. And this is a pentagon, so this is going to be 5 minus 2. So I'm going to have 180 times 5 minus 2, which is basically going to be 180 times 3. So I'm going to get 540 total degrees. So to figure out the degrees that are in a polygon, we're going to take 180 times the number of sides minus 2. Now 180 is kind of a special angle. We've been seeing 180 a lot so far this year. But what shape have we talked about that always has exactly 180 degrees? So what is the shape that we've talked about that has exactly 180 degrees? Go ahead, somebody could shout it out. The triangle. Now, as you look at a polygon, and this one is a pentagon, it's got 5 sides. If you start to connect vertices to make triangles, how many triangles am I constructing when I connect these vertices? I got 1 here, 2, 3. So the number of triangles in a polygon is always going to be 2 less than the number of sides. So that's where that formula comes from. We're going to take 180, because that's how many degrees are in a triangle, times the number of sides minus 2. So you look at one, how many sides is this? 1, 2, 3, 4, 5, 6, 7 sides. That means there's going to be 5 triangles that I can construct in here. 1, 2, 3, 4, 5. So we take 180 minus the number of sides minus 2. Now we're not quite done yet for this problem, because we're going to set up a little algebra, but we've done problems like this. So next what we would do is we would take 540 equals, and then we've got all these angles in here. So we're going to set up our algebra: x plus 100 plus 117 plus 105 plus 115. So eventually what we would do is we would just subtract all those angles over and then figure out how many degrees are remaining for that x angle. And I forgot my calculator here. So we would take 540 minus all those angles. And we'd be left with the x angle right here would be 103. So using kind of both topics from chapter 6 is section 6.1 is finding the total degrees in a triangle or in a polygon, and then also looking at setting up an algebra problem to figure out the missing link. So when you're looking at that formula, that's where that formula is coming from. Is really it's just looking at, well, how many triangles can I construct inside that polygon, and that's going to help me start to find the total number of angles. Secondly, then we'll look at section 6.2. And section 6.2 starts to now just focus on parallelograms, and that's where we're going to kind of stick with. The rest of chapter 6 is focusing on parallelograms. And you're going to notice in section 6.2, we're going to start to look at a lot of different theorems and things with parallelograms. The nice thing is tomorrow in section 6.3, or we start to look at section 6.3, we kind of review each of those theorems. We're just looking at the converse of each one. So we're looking at how can I prove that I have a parallelogram based on the certain stats that I'm given. But in section 6.2, we start to look at some special relationships with parallelograms. And One thing I want you to notice about parallelograms, two sides are going to be parallel. So we got like this side and this side. So if I would extend out parallel line here, you have a transversal, which would be that additional side. These two angles right here are going to be same side interior. So we started studying those back in chapter 3, and then we kind of continued to kind of visit that once in a while. But same side interior angles, you think about what are same side interior angles going to add up to? They're going to add up to 180 degrees. So on this problem, we can set up x plus 53 equals 180, 113 plus x equals 180, and x plus 80 equals 180. So in a parallelogram, you're going to notice that the consecutive angles, they call them, or the two same side angles, are going to always add up to 180 degrees. And that's all because of same side interior angles. So it's a topic that we started introducing in chapter 3. Now we're just relating it to a shape. So since we have parallel lines, all those angle relationships are going to come true. The other big piece of section 6.2 is that the diagonals of a parallelogram are going to be congruent. So whenever you have these diagonals, so connecting P and R, the diagonals are going to bisect each other. So those two segments are going to be congruent. And then those two segments are going to be congruent. And then we can start to solve based on congruence. When we know things are congruent, we know that they are equal to each other. Okay. So looking at this, I know that PT and TR are going to be congruent to each other. So these two I'm going to set equal to each other. So 2x equals y plus 4. And then I know QT and TS are equal to each other. Y equals x plus 2. So those are my two equations that I can start to set up. Now, maybe you're looking at that and you're going, well, let's see. Each equation has two separate variables in it, so I can't really solve for one equation. Well, this is called a system of equations. And with a system of equations, we need to work the two equations together. Well, I can use substitution. Since y and x plus 2 are equal, I'm going to take this x plus 2 and I can substitute it in for that y right there. And we can start to solve it out. So that's what I'm going to take a look at. So I'll take x plus 2, substitute it in for that y, and we'll start solving it out over here. So we get 2x equals x plus 2. And then we had that plus 4 also in that equation. So basically we'll have 2x equals x plus 6. Subtract my x over, x is going to equal to 6. And then once I know what 6x is, then I could figure out y is going to equal to 8. So we're going to start to, as we go through and start to learn all of these theorems about parallelograms, and then in chapter 7, we start looking at similarity. In chapter 8, we look at some trigonometry. We're going to continue to bring in some topics from Algebra 1 to keep fresh on some of those. And one of the topics from Algebra 1 is solving systems of equations either by substitution or by elimination. Well, that brings us to 8:31, and I will let you go for the first part of class. So if you're ready to break off on your own, you've met the first 15 minutes. If you want to stick around for question answers, I will be around to help out with continuing 6.1 and 6.2. But thanks for joining. Hopefully you had a great weekend. And then this will be posted on our class page here in a little bit. But like I said, I'll stick around. If you want to throw questions in the chat or turn on your mic, let me know. I can help you with any problems from sections 1 and 2 so far.